Hello dear viewers, welcome to TV Mathshub. In our today's session, we shall be looking at linear algebra revision questions and answers. For those that are preparing for their final examinations in linear algebra, please make sure you stick around and you will see exactly how to break down the common problems in linear algebra. And I welcome you all to this ultimate study session for your introduction to linear algebra revision questions and answers. My name is TV. And over the next few videos, I will be guiding you through a real university final questions and answers for linear algebra. We will cover all the concepts and methods you absolutely need to know in order to pass linear algebra with better grades. Don't forget to subscribe to this channel. Simply hit the subscribe button. It is completely free of charge. Like and share this video to whoever might need help in linear algebra and those that are preparing for their final examinations. So without wasting time, we shall look at question number 1. Question number 1 has got part A, which says define a linear equation. So let us look at the definition for a linear equation. So we shall be defining a linear equation. So let us look at definition. We shall be saying that a linear equation in any variables, a linear equation in any variables, for example, x1, x2, up to xn, is an equation of the form a1 x1 plus a2 x2 plus up to an xn equaling to b, where we shall be calling a1, a2 up to an as the coefficients. We shall be calling a1, a2 up to an as coefficients, and b as a constant term. The coefficients and the constant term are what we call the real numbers. All these are real numbers, and not all are the coefficients, and not all the coefficients a1, a2 up to an are 0. So not all the a1, a2 up to an are equal to 0. And basically we shall also be saying that the variables, that is x1, x2 up to xn appear, these variables here appear only to the first power. So in general, we shall be saying that a linear equation is simply an algebraic equation where each variable is raised to the power of 1. And in most cases, whenever you graph such equations, you get what we call a straight line. So you define a linear equation as that equation where each of the variables x1, x2 up to xn are raised to the power of 1. And whenever such lines or such equations are drawn on graph, then they form what we call a straight line. In other words, if you have, for example, an equation x plus y plus z equaling to 5, such an equation is called a linear equation because the highest power of the power of x, y, and z is 1. And also, if you have an equation such as square root of x plus y plus z is equal to 5, such an equation is not linear. Simply because the power of x here is not 1. Actually, the power of x is a half. If you have an equation x squared plus y plus z equaling to 5, such an equation is not a linear equation because the power of x is not 1. Even when the powers for y and z are 1, still we shall be saying that this equation here is not linear. Also, don't forget about logarithmic equations which are containing logarithm, equations which are containing trig ratios. For example, you have an equation where you have y plus cos of x is equal to 0. Such an equation here will not be a linear equation. So a linear equation is that equation which is strictly strictly having the variables raised to the power of 1. I hope the definition for a linear equation is clear. Part B, we need to talk about solving the system of equations using what we call elimination method. So let us look at part B. How best can we solve such an equation using what we call elimination method? So we have got our equations, the three equations, 2x plus y minus 2z equaling to 10. We have got 3x plus 2y plus 2z equaling to 1, then 5x plus 4y plus 3z equaling to 4. So let us look at the solution. So given these equations here, we shall give them what we call, let us number them. This is equation 1, 2, and this is equation 3. To solve such equations using elimination method, it is very simple. What you do is you consider one equations. Let us consider equation 1 and equation 2. Consider equation 1 and equation number 2. In other words, when you are using elimination method, make sure that you maintain one of the equations constant and use that equation with the remaining two equations. So we consider 1 and 2, then again 1 and 3. So considering equation 1 and 2, equation 1 we have 2x plus y minus 2z, which is equal to 10. Here we have 3x plus 2y plus 2z, which is equal to 1. So from here you have to eliminate one of the unknowns. So from this we can easily see, we can easily eliminate z since the coefficients are already the same. So looking at the signs, they are opposite signs, so we shall add here. So if the signs are opposite, if you have different signs, you deal with addition. Same signs, you deal with subtraction. So when we do that, we shall be able to get this as 5x. Y plus 2y is 3y. And this will be equal to 11. We shall call this equation number 4. Next, let us consider equation number 1 and equation number 3. So equation number 1 is 2x plus y minus 2z, which is equal to 10. Equation number 3 is 5x plus 4y plus 3z, which is equal to 4. So from here, we ensure that the coefficients for z are still the same. But here, you realize this is a 2, this is a 3. So we need to exchange these coefficients. So we shall have a 3 here, and we shall have a 2 here. So from there, we can get these equations. This is 6x plus 3y minus 6z, which is equal to 30. Multiply 2 here, you will get 10x. This will give us 8y. This will give us 6z, which is equal to 8. So we need to eliminate z. So again here, we shall need to add. We shall again need to add. So when we add here, this will be 16. This will be 11. This will be 0. And this will give us 38. So we shall call this one equation number 5. So next we shall consider equation 4 and equation 5. We have eliminated z here, we have eliminated z here. So we shall consider the two equations which are now containing two unknowns. So from here, let us consider equation 4 and 5. And doing that, we must again eliminate one more unknown. So here we can easily eliminate x. And to eliminate x, you ensure the coefficients are the same. To make coefficients are the same, let us simply exchange these coefficients. So from here, multiply this one throughout. When you multiply 5 with 16, you will get 80x. This is 55y. This is equal to 176. This is 190. This is 190. Then next, this will give us 16 times 5 is also 16 times 5, that is also 80. 16 with a 3 is 48. And 16 with 11 is 176. So from here, we shall again see how best we can eliminate this. So we eliminate x by subtracting since the signs are the same. And that will give us, this will be 0. 55 minus 48 will give us 7y. And 190 minus 176 will give us 14. So we can divide through by 7. and y will be equal to 2. So having got the value of y as 2, we go on and get the value for x and z. So having got the value of y, let us see how to get the value of x. We can consider equation 4 or equation 5. We get the value of x. So let us consider equation 4, which is 5x plus 3y is equal to 11, and substitute for y equaling to 2. So when we substitute for y equaling to 2, we shall have 5x plus 3 times 2, which is equal to 11. We shall have 5x plus 6 is equal to 11. So 5x is equal to 11 minus 6, which is 5. So our value of x will be equal to 1. So we have got the value of x. Next, we need to get the value of y. So let us again consider one of the equations. So from equation, for example, 1, which one is this? So we shall have 1 is 2x plus y minus 2z, which is equal to 10. So for x equaling to 1, y equaling to 2, let us substitute for this. 2 times 1 plus 2 minus 2z is equal to 10. So this is 4 minus 2z. So minus 2z is equal to 10 minus 4. Minus 2z is equal to 6. So z will be negative 3. So clearly we have got the values for x as 1, y as 2, and z as negative 3. Now kindly try some of these questions here. Use the same method, that is elimination method, to solve for these two different systems of equations. So the answers are provided here. For system 1, you have x as 1, y as 1, and z as 1. For system 2, you have p as 1, q as negative 2, and r as 1 out of 2. So make sure you try out these questions such that you grasp the concept very well. Now, having looked at part A and B, let us look at part C. Part C says you are given a 2 by 2 matrix A, which is defined by A, which is equal to this. Given that the determinant of A is equal to 0, find the value of x. So let us look at the solution. We are given this matrix A, and we are told that the determinant of A is equal to 0. So in other words, we are getting the determinant of A, which is 4 plus x. This is x, this is 1, and this is 3. And this one here is equal to 0. So how do we get the determinant of a 2 by 2 matrix? You have the 2 by 2 matrix, which is A, B, C, D. You get the determinant by getting the product of the entries in the main diagonal, that is A times D. You subtract the product of the entries in the minor diagonal, that is B times C. So that is how we get a determinant. So in other words here, we shall consider 3 times 4 plus x. Then we shall subtract 1 times x, and this should be equal to 0. So open this bracket, this will be 3 times 4 plus 3 times x minus x, which is equal to 0. So this is 12 plus 2x, which is equal to 0. And from here we shall have 2x, which is equal to negative 12, divided through by x by 2, and your x will be negative 6. So therefore, the value of x is equal to negative 6. And that will be the required answer for part C. So next we look at part D. So looking at part D, it says find the minor and cofactor matrices of matrix A. So we need to look at the minor matrix and the cofactor matrix. We shall look at the solution. So we are given this matrix here, matrix A. We need to get the minor matrix. So we shall first of all get the minors for each of the entries. Minors for each of the entries. And we shall begin by considering the minor of the entry, which is 1, 1. So minor of entry, which is 1, 1, you will be deleting, you delete row 1, column 1. So you delete out this. So when you delete out this, you will remain with, so you get the determinant of the remaining entries. So when you delete this and this, when you delete this row and this column, you will remain with 3, -7, then 1, and -3. So you get the determinant of this. The determinant of this is the determinant of a 2 by 2 matrix. 3 times -3 will give us -9, minus -7 times 1 will give us -7. So this will give us a plus, and this will give us -2. So this is minor 1, 1. 2, we look at minor 1, 2. Minor 1, 2, you are deleting the first row, second column. You are deleting the first row, second column. So the whole of this is out, the whole of this is out. So what will remain is, we shall remain with 2, we shall remain with -5. This is out, we shall remain, and also this is out, we shall remain with 1 and -3. 1 and -3. So next, get the determinant. 2 times -3 is -6, minus -1 times 5, that is -5. This and this gives us a plus, and this will give us -1. So next we look at M1 and 3. Delete the first row and the third column. So delete the first row, third column. So this is out, this is out. So get the determinant of the remaining one. So if this is out, and also this is out, it means we are remaining with 2, -5. Then here we are remaining with 3 and -7. So this will give us 2 times -7, -14, minus -5 times 3, -15. This will give us a plus, and this will be a +1. So next we shall get the minor of 2, 1. Minor of 2, 1, you are deleting the second row, first column. You are deleting the second row, first column. So after deleting the second row, first column, this is the first column, this is the second row. So when this is off and this is off, we shall remain with 4, -7, 2, and -3. So we shall get the determinant here. This is -12, minus this is -14, and this will give us +2. So this will give us +2. Next we shall talk about M of 1, M of 2 and 2. M2, 2, we are removing this second row, then second column. So next we remove and this. So the whole of this is out, the whole of this is out. So when you remove this one and this one here, you will remain with a 5. You remain with -5 here. You remain with, this is out, this is out, so we remain with a 2 and -3. Get the determinant of this. This will be -15 minus -10, and this will give us -5. So next we shall talk about M of 2, 3. M2, 3, we are removing the second row, third column. Second row, third column. So when you remove second row, third column, you will remain with 5, -5. You will remain with 4 and -7. So this will give us -35 minus this will give us -20, and this will be -35 plus 20, which is -15. And next we shall talk about M of 3 of 2. 2, 3 is done. So we come to M of 3, 1. M3, 1 will give us M3, 1. We now eliminate a third row. Third row is this, and the first column. So you are moving the whole of this and the whole of this. What remains will be 4 and 3, then 2 and 1. So this will give us, this will be 4 minus this will be 6, and this will give us -2. Next we shall talk about M of 3, 2. M of 3, 2, remove the third column. This one is out. The third row, then second column. Third row, second column. So we are removing this column here. So we shall remain with a 5, a 2, then 2 and 1. And this will give us 5 minus 4, and this will be equal to 1. And lastly, we shall talk about M33. M33, you are moving this third row, third column. Third row, then third column. We are moving all these entries in the third row, third column. So we shall remain with 5, 2, then 4 and 3. This will give us, this is 15, minus this is 8. And this will give us 7. So that is how we get the minors of a given matrix. So having got the minors, let us now get the minor matrix. So the minor matrix will be, so M11 is negative 2, so this will be negative 2. M12 is negative 1, M12 negative 1, and then positive 1, that is M13. Then M21 is 2, M21, 21 is here. Then this is negative 5, and this is negative 15. And M31 is negative 2, M32 is 1, M33 is 7. So this will be what we call the minor matrix. So after getting the minor matrix, we now look at the cofactor matrix. So having got the minor matrix, we can now get the cofactor matrix. So we shall get the cofactor matrix by using the minors that we have obtained, because we understand that the cofactor of any entry ij is same as getting negative 1 to power I plus j, then times the minor of that same entry. So when you are considering an entry and you need to get the cofactor of that given entry ij, then you simply have negative 1 to the power of I plus j, then times the minor of that same entry. So for that case, let us look at the cofactor 1, 1. Cofactor 1, 1 is same as getting negative 1 to the power of 1 plus 1 times the minor of 1, 1. So this is same as negative 1 to the power of 2 times the minor of M11. So M11 is a negative 2. So we shall have this as times negative 2, and this is positive 1, and this will remain negative 2. So we shall do the same for the remaining one. So C1, 2 will be same as negative 1 at power 1 plus 2, then times minor of 1, 2. So this is negative 1 to power 3, then times minor of 1, 2. We got that one as minor of 1, 2 as negative 1. So this is power times negative 1, and this will give us positive 1. So let us do the same for all the minors. So to look at the cofactors of all the entries, we shall have that. So the cofactor of 1, 3 is same as negative 1 to the power of 1 plus 3, which is 4. So times the minor 1, 3, minor 1, 3, we got it as minor 1, 3, we got it as 1. So you multiply by 1 here, and you'll be able to get that. 2, 1, the same applies, negative 1 to the power of 2 plus 1, which is 3, times the minor of 2, 1. The minor of 2, 1 is 2, so you multiply by 2 there, and you'll be able to get that. C2, 2, negative 1 to the power of 4, then 2, 2, the minor was negative 5, so we shall have times negative 5 here, which will give us that. Next, 2, 3, 2, 3, that is negative 15, the minor is negative 15, so you get C2, 3, negative 1 to power 5 times negative 15, which will give us 15. This is negative 1 times the negative will give us 15. 3, 2, 1, negative 1 to power 4. 3, 1 gave us negative 2, so you place it there. This is 1, this is 7. So you'll be able to get the values for C1, 1 up to C3, 3. So the cofactor matrix will therefore be, the cofactor matrix is, so it will be So we have C1, 1, negative 2, 1, 2 is 1, 1, 3 is 1. So this is 2, 1, 2, 1 is a negative 2, 2, 2, negative 5, 2, 3, 15. This is 3, 1, 3, 1 is negative 2, 3, 2 is 3, 2, negative 1, and this is a 7. So that will be our cofactor matrix. So we are able to get the cofactor matrix, we are able to get the minor matrix. So that will be answered. So basically the question wanted us to find the minor and cofactor matrices of this given matrix. And these are the minor and cofactor matrices respectively. So having looked at part D, we come to the last part, that is part E. And the part E says find AB and BA and comment on your results when you are given A as this and B as that. So let us look at the solution. So let us look at the solution to this given question. So we shall be saying that we are given A as 3, 1, 1, 2, then 1, 7. B is 2, negative 1, 1, negative 1, 2, and negative 1. So we need to get AB. We need to get AB, then BA, then we comment on our results. So what will be AB? AB is having A, 3, 1, 1, 2, 1, 7. You multiply this together with 2, negative 1, 1, negative 1, 2, and negative 1. So this is a 3 by 2 matrix, 3 rows and 2 columns. This is 1, 2. This is a 2 by 1, 2, 3 by 3 columns. So here we shall see that the 2, this product here can be defined because the number of columns here are equal to the number of rows here. So for that case, we expect to have the result. If this and this are out, we expect to have the result, which is a 3 by 3 matrix. So let us get AB by multiplying. So we shall get a 3. We multiply row by column. So we shall have 3 times 2 plus 1 times negative 1. 3 multiplied with this, 1 with this. 3 multiplied with that, that is the next column, though that is 3 times negative 1 plus 1 times 2. And the next we shall have 3 times 1 plus 1 times negative 1. So we close that. So next we shall have this 0 into this column, 1 times 2 plus 2 times negative 1. Next 1 times, now we are multiplying into this column, 1 times negative 1 plus 2 times 2. Next we multiply the same row into this column, 1 times 1 plus 2 times negative 1 plus 2 times the negative 1. And lastly, we shall have this 0 into this column, that is 1 times 2 plus 7 times negative 1. This into this column, 1 times negative 1 plus 7 times 2. Next we shall have 1 in this row into this column, 1 times 1 plus 7 times negative 1. So this should be able to give us, this is 6 minus 1, this is a negative 3 plus 2, this is 3 minus 1, this is 2 minus 2, negative 1 plus 4, and this is 1 minus 2. And lastly, this is 2 minus 7, this is negative 1 plus 14, and this is 1 minus 7. So our AB will be same as 5, negative 1, this is 2, this is 0, negative 1 plus 4, that will be 3, negative 1. Next we shall have negative 5, this is 13, and this is negative 6. So this is AB, which is a 3 by 3 matrix. So having got AB, the question wants us to get AB and BA. So next let us look at BA. BA is same as beginning with B, 2, negative 1, 1, negative 1, 2, and negative 1. We have to multiply this by 3, 1, 1, 2, 1, and 7. So from there we shall have this as, next we shall see if this can be defined. The product, we need to check if it can be defined. This is a 2 by 3. This is a 3 by 2. So since these are the same, then this product is defined. And our result should give us a 2 by 2 matrix. This and that. So that is basically what we are having. So it can be defined. So let us multiply and get BA. So what will be BA? So BA will be same as row multiply row by column. So 2 times 3 plus negative 1 times 1 plus 1 times 1. Next multiply this into this column. 2 times 1, negative 1 times 2, 1 times 7. So lastly, we get this row into this column first. Negative 1 times 3, 2 times 1, negative 1 times 1. So next this into this negative 1 times 1, 2 times 2, then negative 1 times 7. So this should be able to give us, so this will be 6 minus 1 plus 1. This will be 2 minus 2 plus 7. This will be minus 3 plus 2 minus 1. This will give us negative 1 plus 4 minus, this is 7, minus 7. So this should be able to give us, so we shall be able to get our BA, and BA will be, so this will be 6, this will be 7, negative 2, and negative 4. So this will be BA. So this is 6, this is 7, this one is negative 2, and this is negative 8 plus 4, that is negative 4. So 6, 7, negative 2, and negative 4. 6, negative 2, 7, negative 4. So that will be BA. So next we need to comment on our results. So we have got BA, we have got AB. So this AB is a 3 by 3 matrix. We have seen that this is a 2 by 2 matrix. This is a 2 by 2 matrix. So let us give the general comment. So let us talk about the comment, what will be the required comment there. So we have seen that AB is a 3 by 3 matrix, while we have seen BA is a 2 by 2 matrix. So this means that the two matrices have got different dimensions. Therefore, they have different dimensions. And for that case, they cannot be equal. They cannot be equal. Even the elements within these given matrices are different. So this illustrates that matrix multiplication. This illustrates that matrix multiplication is actually not commutative. Is actually not commutative. So what we are talking about is that AB is not equal to BA. In general, we have seen that AB is not equal to AB, and for that case, and this is also true even when both products are actually defined. So the two matrices are not equal. In other words, whenever you are given to get the matrix AB, don't start with B and then you put there A dust. So if you are talking about matrix AB, begin with A, then get B, put B after. So the order matters here. The order, if it is A first, then B next, begin with this, put there this. But if you begin with B and you put there A last, so this one here will be automatically wrong, because AB is not always equal to BA. It is only under some few circumstances where that will be true. So whenever you are given AB, make sure you strictly get AB, not B times A. So that is all about question number 1. And for this same question, please try out this number here. Try out for me this number, and also do the same as we have seen. So the question says, given that A is matrix 1, 2, 1, 2, 1, and 3, and B is the matrix which is 16, 15, 18, then 20, then 4 and 4. So this is A, this is B. So the same question will apply to this. Find AB and BA and comment on your results. So here you need to find AB and BA. Find AB and BA and comment on your results. Make sure you try out this and see if you are able to follow the same procedures that we have followed in this particular example, where we are given A and B and we wanted to get AB and BA, and again we comment on the results. So use the same knowledge and find AB, find BA, then give your final comment. So that is all about question number 1. That is all about question number 1, which was having actually part A up to part E, and this question here takes an overall of 25 marks. So with that, you should be in position now to solve some similar problems whenever they arrive within the question paper. So that is all for question number 1, and we shall meet in question number 2. Yeah.